For this mini lesson, I'm going to walk through factoring each of these three quadratics. Before we start, pause me and try to factor each one. And then I'll show you the answers quickly, the factored form, and then you can decide which of the examples you want to watch. All right, welcome back. Here are the three factored forms for the three quadratics. Check yourself. What I'm going to do now is I'm going to walk through each example. If you are already good to go on any of them, skip those examples and just kind of move ahead in the video until you get to the one that you're interested in. Here's our first example, and I've also written here just a reminder of these are our three basic steps to factor any quadratic. All right, I'm going to start by splitting the middle term, and to do that I need to find two numbers whose sum is 19, B, and whose product is C times A, -4 times 5, or -20. All right, one has to be positive, one has to be negative, so we're going to want a positive 20 and a -1. All right, those two numbers, -1 and 20, tell me how I'm going to split my middle term. I'm going to have 5x squared plus 20x minus 1x, or x minus 4. Great, split my middle term. Next thing I want to do is I want to factor by grouping. So I'm going to look at my first two terms, make this plus -1, and my second pair, the third and fourth terms. All right, for my first one, the GCF is 5x, so I can factor out that GCF 5x, and I'm left with x plus 4. For the second one, again, I know I want to get x plus 4 here, which means this is going to have to be a positive, so I know I'm going to factor out my GCF of -1, and what's left over is x plus 4. Great, factored by grouping. Now I'm super excited because I see that they both have a GCF of x plus 4, and that GCF can be factored out, and I'm left with my remaining factors, 5x plus a negative minus 1. So that means this quadratic in standard form can be factored into 5x minus 1 times x plus 4. All right, here's the second example, second quadratic that we're going to try to factor. All right, I need to split the middle term, but before I do anything, I'm just noticing 21, 72, and 48. I know they're all multiples of 3. So just like any other factoring, factor out a GCF if there is one before you get going. So in this case, my GCF is 3. So I'm going to factor that out. And I'll have 7x squared. See how many 3's are in 72. There are 24. And then minus 48 divided by 3 is 16. Now the nice thing about this is we have now an easier quadratic to factor. All right, let's try to factor it. Start off by splitting that middle term. I want two numbers that are going to add together to be 24. And multiply together to be 7 times 16. Let's do a quick little problem. So that's 112, -112. To help find those numbers, I'm going to get the prime factorization of 112. I know since it's 16 times 7, I know the prime factorization of 16 is 2 times 2 times 2 times 2, and then times 7. So there's the prime factorization. All right, I need two numbers, one positive and one's negative. So I use my prime factorization to help me along here. I notice 2 times 2 times 7 will be 28, and 2 times 2 will be 4. So awesome, I can make the positive number 28 and the negative number 4. And that's going to work. All right, this tells me how I'm going to split my middle term. So 7x squared plus do 28x minus 4x minus 16. Next up is to factor by grouping. I'm going to take the first two, let's make this plus a negative, and the second pair when I look at the first grouping, I see the GCF is 7x. And I'm left with x plus 4. For the second grouping, the GCF is -4, which also leaves me with x plus 4. Great. And now my last step, I can factor out that GCF. Whoops, did you all notice? I wrote a 2 instead of a 3. There we go. I'm going to factor out that x plus 4, and I'm left with 7x minus 4. So this quadratic has now, when it's factored, 3 factors: 3, 7x minus 4, and x plus 4. All right, here's our last example. Now I look at this and I go, oh, it's not a quadratic. Oh, but I see there's a GCF of x. So I'm going to always start by looking for a GCF and factoring that out. I can factor an x out. I'm left with 56x squared plus 43x plus 5. And now I'm left with a quadratic. Great. So I'm going to try to factor this quadratic. I'm going to try to split the middle term. I'm looking for two numbers that add to 43 and multiply together to be 56 times 5, which is 280. All right, I find it so super helpful, just like on the last example, to use the prime factorization of 280 to help me find these numbers. I know there's a 5, and then 56, the prime factorization of that is going to be 7 and 8. All right, and I know 8 is 2 times 2 times 2. All right, so we have 2 times 2 times 2 times 5 times 7. And there's my prime factorization. Let me just erase this to get this out of the way. All right, now I'm going to be using this. I have an 8, let's see, and a 35. Oh, okay, that does it. Sometimes I don't get it on the first time. Well, yeah, that works. I might have tried 10 and 28. That doesn't work. So I just do different combinations of the prime factorization. I stumbled on it right away. So 8 and 35. All right, so I can split my middle term. And it gets split into, I'll do 8x plus 35x plus 5. My next step is to factor by grouping. Look at my pairs. The GCF for the first one is going to be 8x. And when I factor that out, I'll be left with a 7x plus a 1. All right, and for the second group, it is 5. And lovely, 7x plus 1. Always makes me so happy to see that GCF is a binomial there. And I can go ahead and factor that out. So I have x, factor out 7x plus 1, and I'm left with 8x plus 5 as the remaining factors. All right, so this quadratic, well, this polynomial, it's not a quadratic initially, gets factored into, again, 3 factors: x, 8x plus 5, and 7x plus 1. I hope these 3 examples have just helped you get into the rhythm of factoring. Always try to factor out your GCF. After that, split your middle term if you have a quadratic, factor by grouping, and then factor out the GCF, which should be a binomial. All right, time to practice.